Hello, everybody. Thank you for coming. Subject of today's webinar is access control list. So let me start with a very brief introduction into access control list and what their purpose and what they're supposed to solve. So access control is of authorization, and one of the components of basic computer system security. So three components of computer system security is authentication, authorization, and audit. So access control is the measure of authorization, and it essentially answers the question, if someone, subject S, for instance, have any right to, let's say, if a person can read the document. So having this in abstract form, what in real world it looks like our daily financial security. We authenticate ourselves for our banking institution using card and PIN. Following that, we have authorization from the bank institution based on our account type and current budget, whether or not we can withdraw a desired amount of money or conduct a purchase. And upon successful or unsuccessful completion of this request, information about logged and kept for future audits. So three components of basic security paradigm is implemented in our daily lives. It's very much the same in computer systems. So access control lists are implementation of access control, and there's a different other methods of access control implementations on computer systems, but ACLs at this point of time are more developed and diverse. So they are applied on many different systems, from file systems, network, SQL database, and a variety of protocols. There's a basic terms defined for ACLs. There's a subject, it's a user or group, or any other object that a specific implementation requires. And there's access type, typically would be write, read, execute, list, or any other type of access. And there's an object access control, which is in many cases for address, port, or base. Very important detail is access control list is being attached to an object of the control and not to the subject, unlike different other methods of authentication where authentication rights or access rights associate with subject itself. So let's say we have an object and access control list attached to it. It lists subjects with their rights to this object. Different subjects can have different rights, and they all listed in access control list, or ACL. And that access control list is attached to an object. By doing so, it's very trivial to find any subject that have any right to a given object. However, it's more complex and time-consuming to find any object that specific subject has access right to. So that's a limitation of ACL. So our interest currently in this webinar is application of ACL in POSIX compliant file systems. Why POSIX compliant file systems? Because most of our activities, Compute Canada, WestGrid, or even in local institutional HPC, utilizes mostly POSIX compliant file systems such as Lustre, Ceph, Spectrum Scale, or GPFS, and so on and so forth. Most Linux distributions use POSIX compliant file system, X1, 2, 3, and 4. There's many different file systems, some of them POSIX compliant, some of them not. For instance, NFS is not POSIX compliant file system, or Hadoop. We cannot review all of them, and even within POSIX compliant file system, we cannot review all of them. So we will concentrate on most generic implementation of ACLs that works on major POSIX compliant file systems, such as Lustre, GPFS, or Ext. In this case, with the application to the file systems, objects of ACL would be file or directory, subject would be user or group, and rights, read, write, list, or execute. List, in many cases, substituted with enter. Right. In order to implement ACLs, file systems use extended set of attributes, opposite to standard set of attributes that uses to hold standard attributes of the file or directory. By default, standard attributes take priority in determining access to file or directory. And those standard attributes are created upon creation of the object. When we create file, our information as an owner inserted into standard attributes, date of creation, and basic default settings of access control also set up in standard attributes. And those basic standards of access control determined by the operating system itself and settings of the file system. And in different scenarios, it could be different level of access control. For instance, common is access control rights that give owner of the file or directory full access to it and no access to any other group or to anyone else on the system. That's very common and very prohibitive access control, which can be relaxed further by the owner of the file or directory. Typical view on standard attributes represent name of the file, owner of the file, expressed as a combination of user ID and group ID associated with an owner, date of creation of the object, date of modification of the object, and permission pattern, which expressed in segments that represent permission for owner, permission for group, and permissions for everyone else. So as you can see, the owner in paradigm of POSIX compliant file system represented by user and group combination. And it's always associated like this, but depending on configuration of the operating system and file system, group might have or might not any access to the object. And operating system, based on the same default settings of the access control, determines whether everyone else can have any access to a specific file or directory. And default settings in many systems are no access for everyone else. Now, if we look at the settings of standard attributes of the file or directory, it is obvious that there's a limitations because there's only one user and one group associated in standard attributes with ownership of the file, and therefore it's one-to-one relationship between user group and their rights to the file. And by default, everyone else has no access to the file by any way, making this file impossible to grant more fine-grained control. And if we even want to use standard attributes for that, it requires us to add many other users to the same group that we have assigned one type of access. What if we want to assign different types of access for different groups? In order to overcome these limitations, extended attributes being used. Extended attributes essentially a set of attributes supported by the file system for every file or directory. And they can be used for multiple different purposes depending on the file system and operating system implementation, such as reach metadata, some policy attached to the object, and of course ACLs being stored in extended attributes. So let's look at the scenario where we have a file, we have an owner of the file, and we have several users, several groups, and everybody else that we would like to have some level of access to this file. So using extended attributes, we can create ACL attached to the file and define in this ACL what type of access allowed to this file for user D, group B, group A, and user C. Now, by default, extended attributes will inherit access right for this file for everyone else. So if we prohibit everyone else, except specifically defined groups and users to have any access to file, extended attributes and ACL will have no access for everyone else. So in what cases we would use ACLs and why they have any benefit for us? So if we have a number of files and directories owned by the same user, and we require different access level to these files from different users or groups, that can be only achieved with ACLs. If number of files or directories owned by different users needs to be accessed in shared environment, that can be achieved only with ACLs. Unlike standard attributes that created automatically upon creation of the file or directory, extended attributes require manual creation and modification. Another limitation is only owner of the object with the right access to the object can create ACL, because in order to create it, you need to write information into attributes of the file. Typically, Linux operating system provides commands that implement tools for managing ACLs of the files and directories. So that would be the following scenario. Owner of the group of the file or directory using command line interface, execute command required to create ACL and writes it into the file. It can only be done if write access is allowed. That implies that if we have a group of people, for instance 3 people, that have a write permission to a file, and this file also owned by a user, that any of these three members of the group can create ACL on this file, because being primary group of the owner and having write permissions, they can execute command and write ACLs. They can also modify it after initially created by owner. So typically this is how ACL would look in tabular form. It would have a type of the subject, the name of the subject, then the rights that subject have, and the flags associated with this entry. So each line in this table would be called ACL entry. And each ACL entry is being examined every time access to the file is being executed by a user or group. So the big difference between entries marked as default and entries that are not marked as default is that default entries not apply access control to the file itself or directory, but rather instruct how access control will be applied to all objects that inherit this access control from its parent. And that makes sense for directories rather than having default ACL entries for file, which is possible. Most useful purpose of this is to assign them to directory. So if directory has ACL with default entries, everything created within that directory will inherit the same ACL entries automatically. So let's run through simple examples. So let's create a directory called webinar. It will assign standard attributes to this directory, and if I perform this activity, the owner of the directory would be me, and the group associated with ownership of this directory would be also my own group, which contain only one person. Then, using a standard command for setting ACLs, setf ACL, I will set up default ACL entries. -D instructs setf ACL to create default entry. -M instructs it to create or modify entry. And then following is the entry itself. G signifies the group, then the name of the group, and then access rights, and then the object. Important to note that name of the group should be resolved on the system. So that group must be defined on the system on which I run setf ACL, and the object should be visible to the command. So if setf ACL cannot find webinar directory or file in current location, the command will fail. And then next command will create normal entries for ACL. Note that there's no -D option, and then just a standard -M and then entry itself. And then I have a directory with extended attributes containing ACL, containing default and non-default entries. Now, if I touch or create a new file inside directory webinar, that file will have inherited extended attributes with ACL attached to it, having default entries propagating into the file ACLs automatically. So everything will inherit within this directory, will inherit my settings of access control. So if I look at webinar directory standard attributes prior to applying ACLs, yeah, I would find this. Standard permission mask. First segment represents access rights for the user. Second represents access rights for the group. and third represents access right for everyone else. And get FACL command allows you to read any access control rules associated with an object. Even if you don't have extended attributes defined ACL for the object, standard attributes still applies, and get FACL can read it. So this is how standard attributes would be interpreted by get FACL. File owner is Sergey, group owner also Sergey. User can read, write, and execute. Group can read and enter, and others can do nothing. So after we apply ACLs to directory webinar and run get FACL again, we'll see more information appearing in access control list. And one of the important things, you can see that there's default ACL entries appears. Default entries cover user, group, and mask, and others. An important piece here is now we have access mask. And access mask is a combination of standard access attributes and extended access attributes. It's overlap between what we allow to do by using standard attributes and ACL. And it's a unity. So if you allow read in both, mask will allow read. If you allow read execute in one and read in another, the mask will present only read, because only overlap in attributes will be allowed. Now, if we look at content of the directory, we will see that now each entry has a plus attached to it in attribute segment, and that indicates presence of extended attributes and indirectly can tell us that there's ACL attached to the file and to directory. So as long as default ACL entries set up on a directory, everything that we do within that directory, create file, modify, create directory, and create file within that new directory, will inherit ACL from entries defined as default. That provides very easy and automatic way of managing access to directory that we meant to be sharing with other people. But what if we have a directory that we never shared before or never added additional users to access the directory, and we have mass of information in it? So we can run recursive set FACL, setting access permission to everything inside directory. So this is a command with -R, and definition of the ACL on existing directory will take care of this. Now, that means that everything that we have inside the directory, we apply this command on, will have the same ACL throughout. Now, if we want to change it, we either go one by one and change ACLs on individual files or directories, or we use some sort of automation tools, some sort of scripting or productivity tools. That brings me to how to avoid large overhead of access control on large number of files, directories using ACLs. So there's many different rules and approaches that I found over years, but it can probably be summarized as these four major rules. So use default entries as much as possible, because as soon as they set up, your ACLs will be set up for everything within that object automatically. You don't have to take care of this. It will be done by operating system and file system itself. Use group-based ACLs as much as possible, because it's much easier to assign one group to access directory and then manage members instead of managing ACLs on individual files if you allow access to an individual user only. Keep record of implemented ACLs. This is very important because extended attributes are not preserved when files or directories cross boundaries non-POSIX file system. It's important because if we copy a file that has ACLs somewhere that is not POSIX compliant, ACLs will be lost, and when you copy the file back, it will not have any ACLs. Also, there is scenarios when we need to track who we gave access to what, and if we manage large volume of data, running on the file system and querying ACLs from every file and directory will be very time consuming. So keeping a record of ACLs we create is a good habit. And of course, in order to do this, implement automation, some sort of ACL management automation that either you write yourself using any scripting language that you have proficiency in, or use ready developed tools for this. I know that there are tools exist. I don't use any of the standard tools. I write my own productivity scripts, and they're pretty straightforward. So one of the methods of managing sharing access or targeted access to data otherwise unavailable to others, and successfully implemented in many places, would be group-based ACLs. It's a powerful method. It allows us to manage small number of groups instead of large number of files, and provides flexibility and very fine-grained control over what data can be accessed by what subjects. So Compute Canada implements this on pretty much every system, on Cedar Graham and others. And in order to use this method, you still need assistance from support personnel. So there's 3 steps to do ACL control based on groups. So first, we need to request creation of the group from support. So send email to support Compute Canada, and special group will be created within CCDB, and then this group will be available on every system in Compute Canada. This request should be approved by PI if you're a sponsored user, or if you're PI, it's sufficient to have your request for this. It will help tremendously to support personnel if desired name of the group provided, group members provided, and what target will be used for applying of ACLs. So as soon as you receive response from Compute Canada support, whether you are assigned as a manager of the group or the owner of the group, you can use online group management interface at cctbcomputecanada.ca, and using this interface, you will be able to see all groups associated with your name, and you will be able to manage group membership. You can assign manager, you can assign member of the group, or you can remove members if they're no longer needed. So these changes will be applied to every system that Compute Canada runs. There will be a slight delay, maybe an hour or two, between changes and application of them on the systems. And then when group is populated with members and propagated to all file systems in Compute Canada, using SSH client, you can log in to a specific system and use setFACL command to apply ACL rules to specific object using this group as a parameter. Now, in order to do this, you should be able to write to the object where ACL is applied. So let's look at the case where we need to apply ACL to a directory that lives inside a large directory tree. So you're all familiar with organizational file systems in Compute Canada. So typical work for many users is to have on project file system their project directory, and then within that project directory they have their own subdirectories that they want to share, or something within their own directories they want to share as well. So we have a sub-directory called project RRG Trent Bob23 share. So this directory we want to share or give access to members of a group called ACL-Trent_share. So this group we assume already created. We assume this group already have assigned members, and what we need to do is to let members of that group have read-only access to directory marked with the red color on the screen. So as you can see, file system, project directory, then subdirectory of the user, and then target directory, they all represent some form of tree or ladder, and access to the bottom directory is only possible if you can access every directory above it. Meaning, if we try to access directory share inside subdirectory Bob23, even with ACL applied to it, we won't be able to do it, because by default, project directory is accessible by project members only. Bob23 directory accessible by user Bob23 only. So group ACL-Trent_share cannot even traverse to directory they have right to, because every directory on their way is locked. However, file system itself is open for all registered users, and they should be able to see project directory to which they need to enter, but unfortunately they cannot do it. Now there's a standard way of doing it. We need to allow entry into project directory RRG Trent. So that's the command that does it. We change access control to the directory, allowing everyone entry. So everyone entry access allows only everyone to enter directory and nothing else. You cannot read content of the directory. You cannot traverse anywhere else within directory. You can enter it. So next step, we need to enter directory of Bob23. The same command allows everyone access to user directory Bob23 within RRG trend directory. So the same rule applies. Entry access allows only entry to the directory, does not allow access to data within directory. And now, with this resolved, we can apply ACL command to a directory, changing everything within it with setf ACL, applying read-only access and entry for all members of ACL trend share group to directory itself and its content recursively. And after that, we set up default ACL entries for this directory, so all new content will inherit the same ACL as we just set up. So that is done with parameter -d. So that's pretty much all I prepared to tell about access control lists, and I hope that we can discuss in more like question-answer if you have any questions or you would like to know more.
Hi, Sergey. Thanks for the presentation. There were no questions in the chat so far. So everybody, if you want to ask a question, you can either type it or unmute yourself and then ask by audio. So I have a question. How do you set up access if you want? So let's say you have a team and you want to give write access to several people to a joint project folder where they can remove files, they can edit files. I mean, one example could be setting a Git repository right on the right inside the file system, right? So you want to have a directory that everybody in the group can write to. So are there any special things on top of what you mentioned to do that?
So if this is something that can be described with this scenario, so you have a group of people and you have a directory somewhere and you want to get access to this directory for read-write to this group, the only thing that changes is essentially access right. You add write permission for this group, and now if you apply it as a default setting, every new file created or new directory created within will inherit write permission to it for that group. Everything else applies the same way. You need to have, or group need to have access to the object where ACL applied. And that access to the object only requires entry to directory. So if we have very long nested directory tree and you're sharing write access to a directory somewhere on the bottom, it could be difficult to go through each parent directory upward and assign this attribute for entry if you do it manually. There is a way, and I can recommend to look into find command on Linux. It's your best friend if you want to deal with large nested directory trees. But using some form of scripting, it's quite trivial to allow traversal from the top of the directory tree to the object of the ACL. So if this is done, then ACL takes effect. And you might as well apply ACL to every parent directory in the tree. However, as I mentioned before, ACLs cannot survive transition to non-POSIX file systems. And because we do backup and restore on most of our file systems, if your data was backed up and restored the restore copy of the data does not have any extended attributes populated because tape cannot hold extended attributes.